All right, here we go. New vocabulary right off the bat. Might want to just have this on hand in case some of us want to take a nap, just in case. Okay, first off, first vocabulary term, a central angle. It is an angle inside your circle, an angle that is formed inside, but here is the requirement. The angle inside, the vertex must be the center of the circle. So does everyone see angle AOB that is formed in circle O right now? That is called a central angle. Why? Where's the vertex? At the, don't say in the middle. It's not, there's no middle here. It's where? In the center, all right? Any central angle is formed by where the vertex is in the center of the circle. All right, so for example, for us here, I have angle, this isn't going to work for me. I have to get it up there first. So if you're wondering why this is taking so long, that's why. Okay, maybe. Let's see. Angle. Yeah, see, I'm writing here. Okay. Angle AOB is a central angle. Maybe. An arc, piece of the circle, going around the circle, a piece of the circle. There's a bunch of arcs you could give me here, bunch of arcs. I could name, everyone see this one right here that I'm tracing out here. From A to C. Symbol for arc. Looks like a little umbrella. All right, oh, that's arc AC. Now, some of you may argue, well, how do I know you're not talking about this arc AC? Valid point. How do I know I'm not talking about that one? Well, if I wanted that one, I would name it with the letters in between as well so you knew what direction we were going in. So that would be arc ABC if I wanted that one. Are there other arcs up here? Sure, arc BC, arc AB, all right? There's a lot of other arcs here. But you follow the direction of the letters. Follow the direction of the letters. Last thing here with arcs and central angles. How do you actually find what the measures are? Pretty easy theorem, your first theorem of the circle unit. The measure of a central angle is equal to the measure of the arc. Here's what I mean. If this central angle is 74 degrees, arc AB is also 74 degrees. The measure of the central angle and the measure of the arc are always equal. Now, I want you to understand what I mean by 74 degrees on the arc. How many degrees in a circle? So when I give the measure of an arc, that's how many degrees it is out of a total of 360. So when I say the measure of arc AB is 74 degrees, I'm telling you guys, hey, that's 74 degrees out of a total of 360. All right, I'm not telling you how long it is. We'll get to that in a second. But this is 74 degrees out of a total of 360. Central angle, arc, always equal to each other. Questions there? Okay, different types of arcs. Let's try this again. Maybe. Here we go. Great. My pen's right here, and we're ready right there. Good. Okay, semicircle. Semicircle, half a circle. I'm going to ask somebody right now, diagram 1, name a semicircle. Name an arc that would represent a semicircle here. Arc. What am I looking for here? 23. Name a semicircle by its arc here. T. RS, that's fine with me. TRS. You could also do TS. That was right, too. Going from T to S. That's correct. What if the arc's bigger than a semicircle? I call it a major arc. Major arc. Something bigger than a semicircle. So let me go to this diagram now. I need somebody to get me a major arc here. Something bigger than a semicircle. 6. RTS. That's a good major arc right there. RTS. Yep. So major arc, bigger than a semicircle. Something smaller than a semicircle, minor arc. Minor arc, and that's what I'm going to ask somebody for right here, right now. A minor arc. Nine, minor arc. RS, fine with me. We could have gotten multiple ones there. What else would be considered a minor arc? RT, yep. Okay, something smaller than a semicircle. All good there. Different types, because you're going to name them on the assignment tonight if you try it. Adjacent arcs. You guys probably the word adjacent all throughout your math career. Get off, about time. Okay, all throughout your career, next to, right? Two arcs that are next to each other. Great. And they also have to share a common point on the circle. Also have to share a common point. So let's name for me two adjacent arcs. 10. Two adjacent arcs for me. AOB is not an arc, it's an angle. I only want to use points on the circle when I name an arc measure. I don't want O anywhere in there. AB is adjacent to CA, fine. They both share point A. Could I have also gone CB and AB? Yes, I could have. All right. Okay, now let's find the measures. How many degrees in each of these arcs? Let's start with arc AE. Everyone see where arc AE is. How do you find the measure? You go back to the theorem. The arc is always equal to its, oh, no, don't say angle. Come on. We're going to have a lot of angles in this unit. Central angle. So does everyone see the central angle that belongs to arc AE? ACE, angle ACE. If you can find the measure of ACE, you found the measure of arc AE. And what do we got? 9. What do we have? 90 degrees. Everyone all right? 90. It's equal to its central angle. Let's keep going now. ED. ED. Arc ED. Find its central angle. You found the arc. 30. ED. 50. How'd you get 50, by the way? Okay, you could still use your, look, there's 50. They're linear pairs. I don't need a circle rule for that. D to B to A, follow the letters. D to B to A, follow the letters. 24, what do you got for me? D to B to A. No one's there, all right. How about 18? What do you have? 220. What'd you add up? 130 and 90. There you go, perfect. 130 and the 90 make up that arc. AED, follow the letters, follow them. 27. 140, yep. What'd you add up? 90 and 50. ABD. Should look a little familiar. 5, ABD. 220. It's the same as DBA in number 3. We just reordered the letters. And then finally, BD. 1, BD. 130 degrees. Any issues? Because I'm going to take a look. Not yet anyway. Not yet. We all good? And then probably from your elementary school days, we got our good old pie chart here. You guys have something different. You have AB first. Yep. Okay, AB. So the measure of arc AB. Now you look at AB, it's worth 20%. That doesn't mean 20 degrees. All right, it's in percent, not in degrees. But it's 20%. Is that 20, correct? It's 20% of how many degrees? 360. How do you calculate what 20% of 360 is there? What do you want to do here? 25. What do you want to do?
Multiply 360 by 0.2.
There you go. 0.2. 0.2. And what is the measure of AB now? 29. What do you got for me? 72 degrees. Got it. And we'll do the same thing now for arc CD. But now it's 18% of the whole graph. How do you want to calculate CD now? 21. How do you want to calculate CD? 0.18. And arc CD has a measure of 24. That's right, we don't have one. Here you go, 26. 64.8, nice job. Okay, we're all good there. On measure, it's in degrees out of 360. All right, because now what we're going to do is, actually, how long is it? If I cut it out, straightened it, how long are these arcs now? So not in degrees, inches, feet, centimeters, millimeters. Okay, how long is an actual arc? And that's going to be a new formula. So here comes our second formula after circumference. How do I find the length of an arc? So does everyone see the difference what we're doing? When we ask for measure, that's how many degrees out of 360 it is. Length is how long is the darn thing now? How long is it? Here's how we find it. We take the measure of the arc, which is what we've been finding, the degree measure, out of 360. So what's the measure of it out of 360? Times, and this is going to look pretty familiar. What's that? Circumference. Think about it. What part, we're finding what part of the circumference it is. All right? What part of the circumference it would be. So there's our second formula here for the unit. Measure of the arc over 360 times pi d. All right, let's try it out. Length of each arc in terms of pi. What did terms of pi mean the other day? What am I looking for here? 6. What am I looking for when I ask for terms of pi? Have a pi in the answer. Don't hit your pi button on the calculator. Okay, leave the pi immediately in your answer. So AB right now, arc AB. This one right here we're talking about, by the way. This is arc AB. How long is it? All right, let's go to the formula. Number 16 here. What is the measure of arc AB? 90. It's equal to its central angle. 90 out of 360 times 23 diameter length, 24 pi. And as Grace just said, keep the pi in your answer. So I'm going to my calculator right now, and I'm doing 90 over 360 times 24. And 16 when you're ready. 6 pi, thank you very much for remembering. If your diagram has units, so does your answer. 6 pi units. That's how long AB is. If you actually wanted to find a number value, just do 6 times pi, and that's how many inches it is. C to D to E, C, D, E. Follow the directions of the letters, because that 40 will not appear in our formula. That 40 should not appear. What is the measure of CDE? How many degrees in CDE? 7. How many degrees in CDE? How'd you get it?
360 minus.
Good. 360 minus 40 gives me the 320 over 360 times diameter length, 13 diameter length, 18 pi. We okay on that setup there? So once again, drop the pi to your drop the pi into your answer. 320 over 360 times 18. 28, yes, no? Not here today. How about 8? 16 pi and the units, thank you. And then you have FGH. Follow the direction of the letters. FGH. Measure. 27, measure. 135, 45 plus 90, nice job. Over 360 times diameter. 23, diameter. 6 pi. You can leave this as a fraction or as a decimal, it's up to you. The decimal's not too big. $23. 2.25 pi meters. Yep. What is that, 9/4 pi? 9 pi over 4, if you left it as a fraction. Any questions here? Because now the last problem we'll do together, I'm actually going to tell you what the length is, and I want you to solve for a different part of the formula. That's what I'm going to do here. All right, last part. Find the circumference. All right, here you go. Let's get it. Ready? That's the other formula we're responsible for so far. 6, formula for circumference. Pi d, yep. I give you this 6.09. What's that represent here? 6.09. 10, what's that represent? 6.09. The what? The measure or length? Is 6.09 the measure of it in degrees or the length of it? It's the length of it. Everyone, yes, it's the length. Didn't we just use a formula for that? We said the length was equal to the measure over 360 times pi d. So where's this 6.09 going to get plugged in now? 16, where's this 6.09 going to get plugged in? The length over here now. 6.09, and hey, what are we solving for now? Whoa. That's fine, you could solve for the diameter. But I'm asking for the circumference. What's the formula? Pi d. Isn't pi d in this formula? So all I need your help with is getting this by itself. You can, hey, go ahead. You can, here, go ahead and solve for the diameter. That's fine. But aren't you going to re-multiply it by pi at the end anyway? Okay, so it's kind of you're redoing everything. But that if you want to do it that way, that's fine. So let's get back here. 6.09 equals measure. We do know that. 18, what's the measure of arc JK? 50 over 360 times pi d. All right, now the algebra skills take over. How do I get that 50 over 360 out of there? So I get pi d by itself. 9, how do I get it out of there? Well, it's not really being added, though. Right? It's being multiplied here. A division, yep. So I can divide both sides by 50 over 36, 360. Or did anybody have a different way? I can multiply both sides by 360 over 50 if you wanted to. Okay, your call. If you divide by 50 over 360, I recommend a fraction template or two. I'll go with the second way you guys suggested, which is multiply both sides by 360 over 50. And I believe I gave rounding directions up there. 10th, thank you. Okay, so nearest 10th. 11, nearest 10th here. 33 point. 43.8. 43.8 units, yep, inches. Now again, you guys that wanted to solve for the diameter, you can, right? You can divide by pi, but then what are you going to end up doing when you plug it in the formula? Multiplying it by pi, so you're kind of just going around in a, no pun intended, a circle there, all right? 43.8, all good? You are good. Do not give up on these questions tonight, because tonight I'm going to ask you for the circumference. I'm going to ask you for the radius tonight. What if I wanted the radius of this one? I would divide by pi and then do what? Because that's the diameter. Divide by 2. Don't give up on it tonight. All right, don't give up. I may ask for the measure of it, so you got to put an x up here instead and solve for the rest. All right, do not give up on it tonight.